All right, so this exercise that we're going to be working on is going over 3.4 and 3.5. We're going to start off by just finding the zeros. So starting with number 18, we have g of x is equal to x squared plus 10x plus 23. Normally you'd have this trinomial, you'd set it equal to 0 and find your factors of your c term that add up to your b term. However, 23 is a prime number, so its only factors are 1 and 23. Neither 1 nor 23 are going to add up to give you a number that's positive 10. So since you cannot do this by factoring it, easy, trinomial, use your quadratic formula. Your a is 1, b is 10, your c is 23. So if we use our quadratic formula, it's going to give us x is equal to the opposite of b, so negative 10, plus or minus the square root of b squared, so 10 squared, minus 4 times a, which is 1, times c, which is 23, all over 2 times a, so 2 times 1. So this is x is equal to negative 10 plus or minus the square root of 100 minus 4 times 1 times 23 gives us a negative 92 all over 2. That 100 minus 92 is 8, so that's x is equal to negative 10 plus or minus the square root of 8 all over 2. That square root of 8 can simplify. Your 8 is 2 and 4. 4 is 2 and 2. So your two 2's pair up. This then gets written as x is equal to negative 10 plus or minus 2 square root 2 all over 2. So instead of this, we are going to simplify. That 2 goes into both the negative 10 and the 2, so that negative 10 becomes a negative 5. That 2 becomes a 1. You do not touch what's underneath the square root. So it's just x is equal to negative 5 plus or minus the square root of 2. And that is your answer. For number 20, same concept. You have f of x is equal to x squared plus 6x minus 2. There are no factors of negative 2 that add up to be 6. So use your quadratic formula since you have a trinomial. Your a is 1, b is 6, c is negative 2. So this is going to give us x is equal to the opposite of b, so that's negative 6, plus or minus the square root of 6 squared minus 4 times a, which is 1, times c, which is negative 2, all over 2 times a, so 2 times 1. This is going to simplify to be x is equal to negative 6, plus or minus the square root of 6 squared is 36, minus 4 times 1 is negative 4, times negative 2 gives us a positive 8, all over 2. From here, add what's underneath your radical. So x is equal to negative 6, plus or minus the square root of 36 plus 8 is 44, all over 2. That 44 is 4 times 11. 4 is 2 times 2. So those 2's pair up to give us x is equal to negative 6 plus or minus 2 square root 11 all over 2. From here, simplify. Your negative 6, your 2, and your 2 are all divisible by 2. So your negative 6 becomes a negative 3. Your negative 2, or sorry, your positive 2, your plus or minus 2 turns into 1. So that's x is equal to negative 3 plus or minus the square root of 11. For 22, we have g of x is equal to x squared plus 36. For this one, you can use the quadratic formula by saying that your a is 1, your b is 0, your c is 36, and work with it that way if you'd like to. Or you can take what you have there, which is that x squared plus 36, set it equal to 0, and then solve for x. Move your 36 over, subtract it from each side. This is going to leave you with x squared is equal to negative 36. then just take the square root of both sides. You have a negative underneath that radical, so a couple things here. You're going to have x is equal to, you're taking the square root of both sides, so put the plus or minus. The negative gives you an I, and that square root of 36 is 6. So it's just x is equal to plus or minus 6i. For 24, you have f of y is equal to 81y to the fourth power minus 625. You can take the square root of the 81y to the fourth power as well as the 625. So this is going to give you 9y squared minus 25 times 9y squared plus 25. And we just set this equal to 0. You can continue to factor that 9y squared minus 25. This is going to give you 3y minus 5 times 3y plus 5. And then you still have the 9y squared plus 25, because that is not a difference of squares, so you cannot factor that one. Now that we have this completely factored, we can set each part equal to 0 and then solve each part. So this is going to give you 3y minus 5 is equal to 0. 3y plus 5 is equal to 0, as well as 9y squared plus 25 is equal to 0. Working with the 3y minus 5 is equal to 0 first, I'm going to add the 5 over by adding it to both sides. So that's 3y is equal to 5. And then we divide each side by the 3, not to take the square root, divide by 3. So that's y is equal to 5 over 3. For the 3y plus 5 is equal to 0, subtract your 5 over. That gives you 3y is equal to negative 5. Then divide each side by the 3. So y is negative 5 over 3. Lastly, for the 9y squared plus 25 is equal to 0, move your 25 over first, subtract it from each side. You have 9y squared is equal to negative 25. Then divide each side by the 9. So you have y squared is equal to negative 25 over 9. From here, take the square root of both sides. You have a negative underneath that radical, so take the negative out. Make sure you put the I in front of it. Then also put the plus or minus there and take the square root of the 25 and the 9. So you have y is equal to plus or minus, the square root of 25 is 5, over the square root of 9 is 3, and you have that I. So you have four solutions here. You have that y is equal to plus or minus 5 over 3, as well as y is equal to plus or minus 5 over 3i. Keep in mind with these, when you do have that negative underneath the radical and your radical simplifies, that I goes last because it's imaginary. So you don't want to put an imaginary part in front of a real part. If we move back over to 26, we have h of x is equal to x squared minus 4x minus 3. You do not have factors of negative 3 that add up to be negative 4. So you have a trinomial, use your quadratic formula. It's the easiest thing. You have an a of 1, a b of negative 4, and a c of negative 3. So we're going to have x is equal to the opposite of negative 4, plus or minus the square root of negative 4 squared minus 4 times 1 times negative 3 all over 2 times 1. Your double negatives turn into positives, so that's x is equal to 4 plus or minus the square root of 16 plus 12 all over 2. That 16 plus 12 underneath that radical gives us 28, so x is equal to 4 plus or minus the square root of 28 over 2. That 28 simplifies because it's 4 times 7, and the 4 simplifies to be 2 times 2. So this gives us x is equal to 4 plus or minus 2 square root 7 all over 2. Again, your 4, your 2, and that denominator of 2 can all simplify by dividing each of those by 2. So 2 becomes 1, 2 up top becomes 1, 4 becomes 2. So we have that x is equal to 2 plus or minus the square root of 7. For 28, you have x to the 4th power, f of x is equal to x to the 4th power plus 29x squared plus 100. Your factors of 100 that add up to be 29 are 4 and 25. So this can factor to be x squared plus 4 times x squared plus 25 is equal to 0. From here, we can set each part equal to 0 since you cannot factor either of those. So that's going to be x squared plus 4 is equal to 0, and x squared plus 25 is equal to 0. And then we just solve. So subtract your 4 from both sides. You have x squared is equal to negative 4. And then take the square root of both sides. So that way x is equal to plus or minus 2i. For the x squared plus 25 is equal to 0, subtract your 25 from both sides. You have that x squared is equal to negative 25. Then take the square root of both sides. So x is equal to plus or minus 5i. So both of these, or all 4 of these, are your answers. For number 30, you have f of x is equal to 3x cubed minus 2x squared plus 75x minus 50. Those 2 sets of parentheses that are there for you indicate that you're going to use your factoring by grouping method. If you have 4 terms on the one side of your equal sign, when everything is moved over to the same side, and it's either equal to f of x equal to whatever, or 0 is equal to, then factor by grouping if you can. For this one, you can. So we're going to factor out from the first set of parentheses the greatest common factor, which is x squared. From the second set of parentheses, your greatest common factor is a positive 25. So this is going to get rewritten as x squared times 3x minus 2 plus 25 times 3x minus 2 is equal to 0. Remember, when you factor out your greatest common factor, what's left over in the parentheses is literally what's left over after you factor out that greatest common factor. So from here, since your 2 sets of parentheses that are left over are identical to one another, the 3x minus 2, you're going to rewrite one of those one time, and then you're going to form another set of parentheses with what you factored out as your greatest common factors. So x squared and the positive 25. You cannot factor either of these sets of parentheses any further, so set them both equal to 0 and solve. So you're going to have 3x minus 2 is equal to 0, and x squared plus 25 is equal to 0. For the 3x minus 2 is equal to 0, add your 2 over. So that's 3x is equal to 2. Then divide each side by the 3. So x is equal to 2/3. For the x squared plus 25 is equal to 0, move your 25 over by subtracting it from each side. You get x squared is equal to negative 25. And then take the square root of both sides. So you get that x is equal to plus or minus 5i. So the 2/3 and the plus or minus 5i are your solutions. For 32, we have f of x is equal to x cubed plus 11x squared plus 39x plus 29. We have 4 terms on that right side of that equal sign. However, you cannot factor them by grouping. The reason why is because between the 39x and the 29, your greatest common factor is only 1. If you factor out a 1, it does not change the 39x nor the 29. If you factored out the greatest common factor between the x cubed and the 11x squared, you'd be left with x plus 11. And x plus 11 is not the same thing as 39x plus 29. So, before you went on Christmas break, we solved these using your synthetic division when you factor or when you find your factors of your constant. Your constant in this case is the 29. Your factors of 29 are plus or minus 1 and plus or minus 29. Use those factors and synthetic division in order to find which one gives you a remainder of 0. Whichever one gives you a remainder of 0, that's going to be a solution. Whatever you have left from that statement is going to be your new polynomial that you're solving for. If we use synthetic division, and let's say the positive 1, we're going to have the 1 in our box. On the outside, we're going to have 1, 11, 39, and 29. Remember with these, if you are missing a variable with a power, so let's say you have an x cubed, then it jumps to x. There's no x squared, you'd place a 0 in for that term. You are going to pull down your first term, which is that 1. Multiply the 1 that you just pulled down by the 1 that's in the box. 1 times 1 is 1. Add it to the next term that you have there to the right. So 11 plus 1 is 12. Do the same thing over again. 12 times 1 is 12. Plus 39 gives us 51. Times 1 is 51. Plus 29 is going to give us 80. That is not 0. So that 1 does not work. Try another one of those factors. If it was me, I would try negative 1. If we try negative 1, we have 1, 11, 39, and 29. Your 1 drops down. 1 times negative 1 is negative 1. 11 minus 1 is 10. 10 times negative 1 is negative 10. 39 minus 10 is 29. 29 times negative 1 is negative 29. 29 minus 29 is 0. That 0 is what we are looking for. So that negative 1 is a solution. Circle it, highlight it, put a star next to it, check it, do something to remind yourself that that's one of your solutions, because you're going to continue to solve this using the 1, the 10, and the 29. This 1 gets an x squared. The 10 gets an x, and the 29 is your constant. So this is going to be x squared plus 10x plus 29 is equal to 0. You have a trinomial left. You can simply use your quadratic formula since you do not have factors of 29 that add up to be 10. Your A is 1, B is 10, and C is 29. So if we plug this all into our quadratic formula, we're going to have x is equal to the opposite of 10 plus or minus the square root of 10 squared minus 4 times 1 times 29 all over 2 times 1. This is going to simplify to be negative 10 plus or minus the square root of 100 minus 4 times 1 is negative 4 times 29 gives us 116 all over 2. Now that 100 minus 116 is going to leave us with x is equal to negative 10 plus or minus the square root of negative 16 all over 2. We simplify that square root of negative 16 to be x is equal to negative 10 plus or minus 4i all over 2. And then we simplify using our denominator. That 2 goes into the negative 10 and that 4i evenly. So the 2 becomes a 1, negative 10 becomes negative 5, and the 4i becomes 2i. So we just have x is equal to negative 5 plus or minus 2i. So with 34, where is it? Do we have a 34? I don't think we have a 34. Okay, so if we look at 36, we have h of x is equal to x to the 4th power plus 6x cubed plus 10x squared plus 6x plus 9. You have more than 4 terms here, so I don't expect you to factor it out in order to solve. You can use your P over Q or your synthetic division by finding the factors of your constant, which in this case is a 9. Your factors of that 9 are going to be plus or minus 1, plus or minus 3, and plus or minus 9. We're gonna use the ones that actually work, but if it was me and I didn't do this prior to, I would start with the 1, then go 3, then 9. It's totally up to you which one you choose to start with. But again, we're gonna start with the one that actually works out. So we're gonna choose a -3, because like I said, it works out. On the right side of your box, you're gonna have a 1, a 6, a 10, a 6, and a 9. That 1 drops down. 1 times -3 is -3. So then we have 6 minus 3 is positive 3. 3 times -3 is -9. Add that with the 10, that gives you 1. 1 times -3 is -3. Add that with the 6, that gives you 3. And 3 times -3 is -9. Add that with the 9, that gives you 0. So this is going to give you the new polynomial of x cubed plus 3x squared plus x plus 3 is equal to 0. You have 4 terms with this one, so try to factor it by grouping. If you group the first 2 terms and the last 2 terms, your greatest common factor from the first 2 is x squared, so you'll factor that out. The greatest common factor from the last 2 terms is 1, so you'll factor out a positive 1. This then gets rewritten as x squared times x plus 3 plus 1 times x plus 3 is equal to 0. Your 2 sets of parentheses are identical to one another, so rewrite that 1 time and then form another with the x squared plus 1. You cannot factor this any further, so you are going to set each set of parentheses equal to 0 and solve. So you're going to have x plus 3 is equal to 0, and x squared plus 1 is equal to 0. Move your 3 over, subtract it from each side. You have x is equal to -3. Then move your 1 over. You have x squared is equal to -1. And take the square root of both sides. So you have x is equal to plus or minus I. So you have 4 answers here. You can write it a couple different ways. You can tell me that you have x is equal to -3 with a multiplicity of 2, and then x is equal to plus or minus I. Or you can tell me x is equal to -3, x is equal to -3, and x is equal to plus or minus I. Because the -3 occurs twice. For number 38, you have f of x is equal to x squared minus 12x plus 34. You have a trinomial here. You don't have factors of 34 that add up to -12, so we're just going to use your quadratic formula with it. So your a is 1, b is -12, and c is 34. This is going to give us x is equal to the opposite of -12 plus or minus the square root of -12 squared minus 4 times 1 times 34 all over 2 times 1. So from here, you're going to have x is equal to 12 plus or minus the square root of 144 minus 4 times 34 is 136 all over 2. So from here, we're going to simplify what's underneath that radical, and that gives us x is equal to 12 plus or minus the square root of 8 over 2. From here, that square root of 8 simplifies to be 12 plus or minus 2 square root 2 all over 2. And then we simplify that by dividing the 12 and the 2 up top by the 2 on the bottom. So that gives us 6 plus or minus the square root of 2. Again, like we said yesterday, remember, if you have a radical, what's underneath in your fraction cannot simplify what's underneath the radical. You got to leave it alone. You can simplify what's on the outside of the radical, but not what's underneath the radical. For For number 40, you have f of x is equal to 2x cubed minus 5x squared plus 18x minus 45. You have your grouping there already, so factor out your greatest common factor from each set. From the 2x cubed minus 5x squared, your greatest common factor is x squared. From the 18x minus 45, your greatest common factor is 9. So this is going to be rewritten as x squared times 2x minus 5 plus 9 times 2x minus 5 is equal to 0. Your two parentheses are the same, so it's going to give you 2x minus 5 times x squared plus 9 is equal to 0. Set them both equal to 0 and solve. For the 2x minus 5 is equal to 0, you're going to add your 5 over. You have 2x is equal to 5, and then you divide by 2 to get that x is 5 over 2. For the x squared plus 9 is equal to 0. Subtract your 9 over. That gives you x squared is equal to negative 9. And then divide each side by, take the square root of both sides, and you get that x is equal to plus or minus 3i. So you have that 5 over 2 and that plus or minus 3i. For number 42, we have f of x is equal to x cubed plus 10x squared plus 33x plus 34. You have 4 terms here, but you cannot factor by grouping. So find your factors of 34. You have plus or minus 1, plus or minus 2. Here, we'll do it this way. Plus or minus 1, plus or minus 34, plus or minus 2, plus or minus 17. You want to find the one that gives you a 0 with synthetic division. Again, I've done this already, so I know that the negative 2 is going to work. I'm going to use that one first. So if we use negative 2, we're going to have 1, 10, 33, and 34. That 1 is going to drop down. Then you have the 1 times negative 2. That's going to give you negative 2. 10 minus 2 is 8 times negative 2 is negative 16. The 33 minus 16 gives you 17. 17 times negative 2 is negative 34. So that gives you your 0. From here, you're going to have x squared plus 8x plus 17 is equal to 0. You don't have factors of 17 that add up to 8. So use your quadratic formula. You're going to have x is equal to negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 17 all over 2 times 1. From here, this is going to give you negative 8 plus or minus the square root of 64 minus 4 times 17 is 68 all over 2. From here, this simplifies to be negative 8 plus or minus the square root of negative 4 over 2, which is then negative 8 plus or minus 2i over 2, which then simplifies further to be negative 4 plus or minus I. So you have a couple answers here. You have that negative 2, you have that negative 4 plus or minus I. So x is equal to negative 2, x is equal to negative 4 plus or minus I. For number 44, you have f of x is equal to x to the 4th power minus 8x cubed plus 17x squared minus 8x plus 16. Again, use your synthetic division. Your factors of that 16 are going to be plus or minus 1, plus or minus 16, plus or minus 2, plus or minus 8, and plus or minus 4. Again, since I've done this for you already, I know that the 4 will end up working. So we're going to try, or we're going to use that one first with our synthetic division. We're going to have 1, -8, 17, -8, -8, and 16. Your 1 drops down. 1 times 4 is 4, plus the -8 is -4. -4 times 4 is -16, plus the 17 is 1, times 4 is 4, plus the -8 is -4. -4 times 4 is -16, plus the 16 is 0. So this is going to give you x cubed minus 4x squared plus x minus 4 is equal to 0. 4 terms, you can factor by grouping. Factor out an x squared from the first set, factor out a positive 1 from the second. This is going to leave you with x squared times x minus 4 plus 1 times x minus 4 is equal to 0. From here, your 2 sets of parentheses are the same, so this is going to be x minus 4 times x squared plus 1 is equal to 0. Set both of these equal to 0 and solve. So you have x minus 4 is equal to 0, and x squared plus 1 is equal to 0. Move your 4 over, add it to both sides. You get x is 4. For the x squared plus 1 is equal to 0, subtract your 1 over. You have x squared is equal to -1. And then divide each side, or sorry, take the square root of both sides. You get x is equal to plus or minus I. So you have the 4 and the plus or minus I for your answers. So if you want to also say that there's a multiplicity of 2 with that 4, you can. For your next set of questions, you are given the zeros and you're asked to find the polynomial function with those given zeros. Remember with these, if you're given fractions, or really with all of them, set them equal to x. Then move the term over to the other side of your equal sign so that way it's equal to 0. Once you have that, you have your binomial that you're multiplying by. So with 45, you have the zeros of 0, -3, 8, and -5. Let's do this. So 45, you have 0, -3, 8, and -5. All right, so that means that we're going to have x is equal to 0, x is equal to -3, x is equal to 8, and x is equal to -5. The x is equal to 0, it's just going to be x that you're multiplying by. So if you want to put that in a set of parentheses, put it in a set of parentheses. For the x is equal to -3, move the 3 over, add it to both sides. So that way you have x is equal, or sorry, x plus 3 is equal to 0. That's going to give you the binomial x plus 3. Put that in a set of parentheses. For the x is equal to 8, subtract your 8 over. That's going to be x minus 8 is equal to 0. So that's the binomial x minus 8. And then with the x is equal to -5, add your 5 over. So x plus 5 is equal to 0. Gives you the binomial x plus 5. This is going to give us x times x plus 3 times x minus 8 times x plus 5. And then you just multiply it out. I would distribute the x into the x plus 3, and at the same time FOIL out the x minus 8 times x plus 5. So the x times x is x squared, then the x times 3 is 3x. Keep that in a set of parentheses. You can then also FOIL out the x minus 8 times x plus 5. So x times x is x squared, x times 5 is 5x. -8 times x is -8x, and -8 times 5 is -40. Combine your like terms. That's going to give you x squared plus 3x times x squared minus 3x minus 40. From here, multiply this out. So you're going to do x squared times x squared, which is x to the 4th power. Then x squared times negative 3x is negative 3x cubed. X squared times negative 40 is negative 40x squared. 3x times x squared is 3x cubed. Then 3x times negative 3x is negative 9x squared. And 3x times negative 40 is negative 120x. We just combine like terms here, and this gives us x to the 4th power minus 49x squared minus 120x. For number 46, it gives us the zeros of 3, 1/2, and negative 5/3. So again, I'm going to start this one by setting each of these equal to x. So it's going to give us x is equal to 3, x is equal to 1/2, and x is equal to negative 5/3. For the x is equal to 3, subtract the 3 from both sides. You have x minus 3 is equal to 0. For the x is equal to 1/2, multiply each side by the 2 to move that over first. That gives you 2x is equal to 1. Then subtract each side with the 1. So that way you have 2x minus 1 is equal to 0. For the x is equal to negative 5/3, multiply each side by the 3 first. That gives you 3x is equal to negative 5. Then move your 5 over and add it to both sides. So that way you have 3x plus 5 is equal to 0. All of these in sets of binomials are x minus 3 times 2x minus 1 times 3x plus 5. I like to multiply the two binomials that have coefficients in front of that x first. So what I would do, which is again my preference, you don't have to do it the same way that I do. If you want to multiply the x minus 3 times 2x minus 1 first and then get that and multiply by the 3x plus 5, that's fine. But the way that I prefer to do it is to multiply the 2x minus 1 times 3x plus 5. So the 2x times 3x is going to give us 6x squared. Then 2x times 5 is 10x. Negative 1 times 3x is negative 3x. And negative 1 times 5 is negative 5. Combine your like terms, and that gives you x minus 3 times 6x squared plus 7x minus 5. Now just distribute the x and then the negative 3 and combine like terms. So x times 6x squared is 6x cubed. X times 7x is 7x squared. X times negative 5 is negative 5x. Now distribute the negative 3. Negative 3 times 6x squared is negative 18x squared. Negative 3 times 7x is negative 21x. And negative 3 times negative 5 is positive 15. Combine your like terms. This gives you 6x cubed minus 11x squared minus 26x plus 15. For 47, it gives you the zeros of 2, 2, 4, and 4. So this is like saying x is equal to 2, x is equal to 2, x is equal to 4, and x is equal to 4. So we move the 2 over by subtracting it from each side. That gives us x minus 2 is equal to 0. Same thing with this one. We do the same thing with the 4, subtract it from each side. And that gives us x minus 4 is equal to 0, which is the same thing for that last one also. So if we set these all in a set of parentheses, we're going to have x minus 2 times x minus 2 times x minus 4 times x minus 4. You know that a binomial squared is a special case. There is subtraction between the two, so we can do that a squared minus 2 times a times b plus b squared if you didn't want to FOIL it out. If you want to FOIL it out, just FOIL it out. So this is going to leave you with x squared minus 4x minus 4 times x squared minus 8x. This is plus 4, I'm sorry, plus 16. From here, multiply it out. The x squared times x squared is x to the 4th power. X squared times negative 8x is negative 8x cubed. X squared times 16 is 16x squared. Then the negative 4x times x squared is negative 4x cubed. Negative 4x times negative 8x is positive 32x squared. Then negative 4x times 16x is negative 64x. Work with the positive 4 now. 4 times x squared is 4x squared. 4 times negative 8x is negative 32x. And 4 times 16 is 64. Not 16, 64. There we go. So if we add all of this together, that x to the 4th power drops down. The negative 8x cubed minus 4x cubed is negative 12x cubed. Then we have 16x squared plus 32x squared plus 4x squared, which is 52x squared. Then we have the negative 64x minus 32x, which is negative 96x. And then the 64 drops down. So that's just x to the 4th power minus 12x cubed plus 52x squared minus 96x plus 64. For your last question, number 48, it gives you the zeros of 1, negative 1, 2, and negative 7/4. So if we set all of these equal to 0, or sorry, set them all equal to x, that's going to give us x is equal to 1, x is equal to negative 1, x is equal to 2, and x is equal to negative 7/4. For the x is equal to 1, subtract it from each side to get x minus 1 is equal to 0. For the x is equal to negative 1, add it to both sides. You get x plus 1 is equal to 0. For x is equal to 2, subtract it from both sides. You have x minus 2 is equal to 0. Then with the x is equal to negative 7/4, multiply each side by the 4. You have 4x is equal to negative 7. Then add your 7 to both sides. So that way you have 4x plus 7 is equal to 0. If you write these all out as binomials, it's going to give you x minus 1 times x plus 1 times x minus 2 times 4x plus 7. Multiply them out. I would multiply the first two binomials together and the last two binomials together. So that x minus 1 times x plus 1 is a difference of squares, so that's going to give you x squared minus 1. For the x minus 2 times 4x plus 7, x times 4x is 4x squared. X times 7 is 7x. Negative 2 times 4x is negative 8x. And negative 2 times 7 is negative 14. We combine like terms, and this gives us x squared minus 1 times 4x squared minus x minus 14. From here, multiply it out. X squared times 4x squared is 4x to the 4th power. X squared times negative x is negative x cubed. X squared times negative 14 is negative 14x squared. Then negative 1 times 4x squared is negative 4x squared. Negative 1 times negative x is a positive x, and negative 1 times negative 14 is a positive 14. So we combine like terms here. We have 4x to the 4th power minus x cubed minus 18x squared plus x plus 14.